Computer vision to ensure safety by monitoring restricted or unsafe areas is an application of vision that's used in industries, it's used in factory settings, it's used in mining industry, and it's also used in your usual security services industry. Being able to specify certain areas which are either unsafe or restricted, and being able to get notifications if some unauthorized activity or unsafe activity take place in that area is something that is of immense importance, and that can be achieved using computer vision. This can help improve safety, this can help reduce accidents, this can help increase security, and this can help avoid any violations. Before we go into the details, let's quickly give you the motivations. So this could be used in factory settings or industrial settings where we can mark restricted area where no one should be, or there may be unsafe areas where no one should be, and this can help improve safety of workers, safety of human beings. Secondly, we can use this for security surveillance if there are highly sensitive areas, or for safeguarding certain places. You can mark restricted areas, and if someone does appear there, you can have a possible alarm or a notification system that can then trigger security responses. This can also be used in traffic management, where there are certain places where, say, cars are not allowed, or only pedestrians are allowed, and if they are restricted areas for certain types of vehicles, being able to tag those areas and being able to find out if there is any car that goes into a restricted zone, either raise an alarm or notify the driver of the car that you are not supposed to be here using a computer vision system, is something that can be used in the traffic management space as well. For understanding how to implement restricted area monitoring using computer vision and to see the code and the demo, make sure you stay tuned until the end of this video. Welcome back to the channel, guys. My name is Dhruv. I am an engineer at Convolve AI. At Convolve AI, we assist small, medium, large enterprises improve their operations, increase their efficiency, and improve the safety and security by using computer vision. If you are looking to incorporate computer vision solutions, you have cameras, you have the existing hardware, but you don't know how you can better make use of this information, or you know how to better make use of the video information that you're capturing, but you still don't know who the right person to talk to is. Here is our contact information. Feel free to contact us, and we would be happy to assist you to evaluate where and how computer vision can help improve the operational efficiency and improve the safety and security of your business. Now, coming to the restricted area monitoring, to start, let me show you a quick demo. So here on the screen, you can see this is a workshop environment, or you can call it a warehouse environment, wherein a worker is moving with a cart, and you can see that there is a restricted area that has been marked in that particular video, in that space, and once the worker walks through that restricted area, the box around the worker turns red and it says unsafe, while when the worker is outside of the restricted area, the box is green and it's a safe place to be. Now, with such a system, being able to detect if a worker or a person is in an unsafe environment, you can ensure that you can take preemptive measures. You can raise an alarm downstream, or you can have a voice, an AI voice, speak through the speaker system, informing the worker to stay out of the restricted zone for their own safety. Or you could just log that information and take some steps later on to improve safety of the workers. Maybe you can put a fence around the restricted areas, and there's n number of things that can be done downstream once you have this information. But having this information and understanding the use of restricted area or violations with regards to restricted unsafe area can help you make those decisions to further improve the safety of your workplace, to further improve compliance, and to avoid workplace injuries and accidents. Now let's go into the code and see how you can implement such a system. So here is the output of the code, which we've already seen, and we can see the worker walking. As soon as they enter the restricted area, their box turns red and later on it turns back to green. So this is an example of how such a system can be used. And now let me first show you the code in terms of how it runs, and then I'll go into the implementation. So guys, let's just quickly run this code over here. Let me just run it again. So the way this code works is it is going to take in ask for some input video. So we'll just give it this input video that we have saved on our machine. Once you open that input video, then you can select the region of interest that you want to mark as restricted, right? So for example, here what we'll do is we'll mark, for example, this area as a restricted region, right? And then we'll just exit, we'll hit the Q button. This shows the masks, right? So this mask has been created based on the input that we gave to the image with regards to the region of interest, and this mask is what is going to be used in order to determine if the person of interest, object of interest, is in that area. So if we close this, and now we'll see that we can see this code ran, the model ran the inference, and we can see the person, once they were in the restricted area, their bounding box turned green turned red, and then later on turned back to green. Alright guys, now that we've seen how the code runs, let's look at the implementation. So guys, this is a standard implementation using CV2 and using your YOLO model from Ultralytics. So these are our imports. So we need the CV2, we need from Ultralytics import YOLO. We're going to use the YOLO model for detecting persons here, and you could use it for detecting cars, you can use it for detecting forklifts, trucks, whatever the case may be. NumPy just for your usual NumPy operations. Then we have this tkinter. This is just for the dialog box that you saw appear from where we can select the input video. This is just to do that. And then OS just for path and OS functions. Right. So guys, here is the first function. This is the callback function, which is used to capture the ROI. So when the code runs, this callback is called in order for you to mark the 4 or 5 points for the ROI. It could be 4 points, it could be 5 points, you could make a square, rectangle, or a polygon. It doesn't matter, it would be able to capture all that information in the ROI. Then comes uh, this is the function. It's called get left lane ROI. It's just a misnomer, don't worry about the name of the function, but essentially the idea is it's supposed to give you the ROI for the restricted area, right? So this function is basically going to show the image frame and let you using the mouse callback select the points that you want to use to define the region of interest. And while you are selecting the points, it's going to keep on waiting through this while loop. And once you hit the Q button, that means you have completed the selection, and then it will return those points which were selected by you using your mouse clicks. Next is the ROI mask. So this is very important. Now, given the ROI, the region of interest points, you need to create a mask, right? So the first thing to do is create a image, basically a mask of zeros. So you create an array of zeros with the same shape as the input image, right? Because you want to have the input image that is coming from your video or from the camera to be the same as the mask. The shape has to be the same. So if your input image is, say, as an example, 1080 by 1250, the mask also has to be 1080 by 1250, because you want to compare the input image and the mask to ensure that to determine if someone is in a restricted area or not. And we'll see how we do that. So you get the ROI mask by first of all declaring zeros, and then you use this CV2 fill poly function, give it the mask of zeros and give it the points, right? So you give it the ROI points. What this function is going to do is it's going to go in for all the pixels in the mask that fall within those ROI points. It will make them 255. So essentially what you're saying is everything else in the mask stays 0, and the pixels that I've selected all the area within that becomes 255. So if you remember, and let's run that again one more time just to show you the so here if I select these 4 points, right, and I'll see that the mask is appeared, right. This mask is made by that function that we were just looking at. So if we go back to the code here, we'll see after that what we do is we load the model. So here we are using the YOLO 12 nano model. You load the model, and then here you create a tkinter object, a window, and over here essentially in this part of the code you're just using it to obtain the input video path, and once you have that input video path, you can essentially start capturing the input video using the cv2.video capture command. So you give it the path to the input video, and then it'll start to capture the input video. This is an error handling step. So if the cap is already open, or it's not been if we could not open the input capture, then it will throw an error. Otherwise, we'll start reading the input information coming in from the input video stream. Now, once we have that, using the input video, we can get the parameters for the width, height, and frames per second for the input video that is being read. And the reason is just to essentially set up our output video writer, right? So what we want to do is we want to read the input video. We want to add our restricted area annotations on top, and then based on whatever the detections happen, we want to be able to get the output video from there. So the output video that you saw during the first demo, and which we can see here, this is the output video that we are trying to generate using this part of the code here. So we are setting up that output video stream. Now here we get the ROI for the restricted area, and then we get the mask for the restricted area. Once we have that, we can just look at it in order to see that everything looks proper. And this is now where all the magic happens. Now you have defined your input video, you've defined your output video, and you have defined the mask, the image mask or the restricted area mask. And now you're going to use all that information in order to obtain the final analytics, which is to ensure or to see if someone appears, and in this case a person goes in a restricted area or not. It's under a while loop, so we are going to run through the loop until all the video frames have been read. The first thing we do is read the input video frame. If there is nothing, then we break out of the while loop. If there is, then we essentially run the image, the frame that has been captured from the input video, through a model, and we get the results. Right now, from the results we look at the bounding boxes. Right, so the results here will be object detection results from the YOLO model, and what we are interested in, we are interested in the bounding boxes. So we get the x, y, x1, y1, x2, y2, which is the top left and the bottom right coordinate of that particular box. We get the class of the box, and we get the confidence in the detection through these objects, or through these parameters of this result object. From here, what we do is we say that for all the objects in the result, we get all these bounding boxes information and the class information. Now for that particular detection, if the class is 0, which corresponds to a person, now you can, if you are doing trucks or cars, you'll change this number corresponding to whatever your model has it for that particular object. In this case, we are interested in persons, so we'll only focus on class 0, which corresponds to people. Basically here what we do is now we basically define a person box, which is gonna have the information about the top left and top bottom right. From the top left and bottom right coordinates of that bounding box, we can generate all the vertices. So this is the top left vertex, this is the top right vertex, this is the bottom left vertex, and this is the bottom right vertex. So we're gonna create the vertices of the of that person's bounding box and have that list in here, and we're going to use this to see the overlap between that person and the restricted area, and this is where we're going to do that. So here this code is going to check if there is any overlap between the person box and the region of interest. And first we say that okay, uh, is within, which basically defines if the person is within the restricted area or not, as false. And if the person's box is within ROI, we check for it, and if it is, then we'll set this is within to true. So here now we're going to look at all the 4 vertices of that person, and for each of the vertex we're going to see if any of that vertex falls within the restricted area, and this is where that is happening, right? So we are going to pass in after these basic checks about the shape and information whether the bound box of the person is lying within the image, because sometimes what happens is if the person is just walking into the frame, the bounding boxes um, for some of the vertices will have accurate values, but for some of the vertices uh, the person may be falling outside of the frame, right? So assume that, say there is a person who just walked into the camera frame, so the AI, the model, can see part of the person and it tags it as a person. However, the left side of that person's bounding box is outside of the image, right? And that's where this if statement, these checks ensure that we are within those realms. The box of the person is in the image. And then what we say is that if the point that for that particular point, that particular vertex, if it falls in the restricted area mask, by checking if its restricted area mask index value is 255 at that point, um, if that's true, then we will set the is within to true. That means the vertex is within the restricted area box. If it is, that means the person is in the restricted area. And if that's the case, we just do the annotation. So we label that as person is in danger, and color it with red instead of the usual green that you'll do. All of this here is again certain little more annotations on top of the image output, just to showcase where the restricted area is and what to draw on the particular image. That is the restricted area label, the box as restricted area, and the person's box. And that's how you do it. So when you run this code, as we've seen before, you'd be able to select the ROI, you would be able to then see the mask, and then you'd be able to also see the live output as someone walks through the restricted area, and they would be labeled in red as being in danger. That's it for this video, guys. So this is how you can determine if someone is in a restricted area where they shouldn't be. And this information, the output from this set of code, this basic code stays the same, and the output from this can be used for various different tasks. Either you can raise an alarm or note this information down for further improvements of procedures in your particular organization or on your factory floors, or you could notify that employee through, or a person through speaker systems, that you are in a dangerous place, please don't be here, it's a restricted area and it's a safety hazard. The sample code for this demo is on our GitHub repository, and the link can be found in the description of the video. Feel free to play around with this and see and share with us if you can do something interesting with it. Again, if you are finding yourself in a position where you want to see how you can use computer vision in order to improve operations, in order to increase efficiency in your line of work, feel free to contact us. I would be happy to help you. We would be happy to chat with you and do an assessment. And again, there is no strings attached. We'd be happy to hear from you. We are interested in hearing different problems that are being faced in the industrial setup in real world that computer vision can help solve. And that is the motto of our company here, to ensure that we can use computer vision to solve real world problems and create real world impact in the real world. Thanks a lot for watching, guys. If you like this video, please hit the like button, subscribe to the channel, and hit that bell icon so you are notified about any new video that we upload. Thanks again for tuning in. I'll see you in the next video.